Welcome to lesson 6.5. We're going to be working on solving some equations here that have different roots in them. Square roots, third roots, fourth roots. Might also have a root to some power. What do I mean by that? Well, here we got a review problem. I've got 5 to the 2/3. That would be an example. If I had x to the 2/3, that's going to be a type of thing we're heading towards solving for, getting rid of that 2/3. But let's go ahead and lead off with a review. 4 to the 1/3 over 5 to the 2/3, not a good thing to leave. Reason is you've got an exponent in the denominator that is a fraction, so you got to get rid of that. We're going to multiply top and bottom by 5, because if I were to rewrite that bottom, it would look like the third root of 5 squared. So I'd multiply by 5 to the, I could either do, if I rewrote it like this, it would be third root of 5, but I kind of like looking at this form right here. And just know that I don't like that fraction. If I put a 1/3 right here, that would make it just a plain old 5 on the bottom. Because when you add these exponents, 2/3 and 1/3, you end up with 1. On the top, exponents are the same, so they stay the same, 1/3, but you take the 4 times the 5 and get 20. On the top, that's like the third root of 4 times the third root of 5, which is the third root of 20. Okay? This is a good answer right here. Or if you want to write it as third root of 20 over 5, that would be good as well. Don't reduce the 20 and 5. If the 20 is in a root, the 5 isn't. My second one here is just a reminder of the square dance. The square dance is first one squared, twice the product, last one squared. Definitely need to be able to square a binomial. Going to come in play today big time. Okay, so getting on to the new stuff. For starters, we're going to have equations that have just one root. And the first thing we're going to have to do then is isolate the root, get the root alone. After you get the root alone, it depends on what form it's in. If it's in radical form, and this one down here, this example one, that's in radical form because it's got a square root. If it's in radical form, you're just going to power both sides by whatever the root is. So down here we have square root, we're going to end up squaring both sides. If we had third root, we'd end up powering both sides by 3. Fourth root, power both sides by 4. If it's written in exponential form, then we're going to go ahead and power both sides by the reciprocal of that exponent. And we'll show you that in example 2. After you power, you get the variable alone, and it's important to check your answers as you may create extra answers. When you power both sides by an even, like a 2, square both sides, or power by 4 or 6, you can create extra answers, so it's important to check your extra answers, or check your answers to see if you do get one that doesn't really work. Okay, so first thing, get the root alone. Minus the 10 over, and divide by -3. We square root of 2x minus 5 equals 2. Once the root is alone, you're going to power both sides by the indicated root. This is a square root, so we square both sides. That'll give me 2x minus 5 on the left. That simply gets rid of the root on the left, equals 4. And we just add the 5, divide by the 2, and we're thinking our answer is 9/2. Again, we squared here, so an extra answer could have gotten created. So you need to go up, plug in 9/2 right here for x, and make sure that this left-hand side equals the 4 that it does. And it does. 2 times 9/2 is 9. 9 minus 5 is 4. Square root of 4 is 2. 3 times 2 is 6. And 10 minus 6 is 4. So when you plug that in there, it does work. So I'm going to go ahead and circle that answer and move on to the next one. Okay, I say look at 2 different ways. I'm just going to do this one way. This one you have to be careful for. I had some notes on the previous page I didn't go over in depth, but this is a situation to be careful for. There's one situation, and that is when you've got an exponent with an even numerator, you must put plus or minus after powering both sides. Like if I told you to solve x squared equals 9, hopefully you would say that it's plus or minus 3. Well, another way to look at x squared is x to the 2 over 1. That 2 is in the numerator. Okay, so since these are an even number in the numerator, you're going to have to do plus or minus. If this was x to the 4th equals 81, you're going to end up with x equals plus or minus 3. It's like 4 over 1. Okay, and you end up either 4th rooting both sides, or you take both sides to 1/4. But when this top part, the numerator is even, make sure you use plus or minus. So that's something to be careful for. Always look for that. There'll be one of these on your test. Put that back down here. So right here, we've got 2/3. 2/3 is even in the numerator. We got 2 answers. This is how it works. Divide by 2. We're going to isolate the root. And we get equals 4. Now you could rewrite this as the 3rd root of x plus 3, that quantity squared, but I think this is much prettier. You're going to power both sides by the reciprocal of the exponent, which in this case would be 3/2. Why do we do that? Because our properties of exponents tell us that we could put these together, the 2/3 and the 3/2, by multiplying. If you multiply those, you get 1. 2's cancel, 3's cancel. So you're left with x plus 3 equals. Now, 4 to the 3/2 simply means the square root of 4 cubed, which is 2 cubed, which is 8. But if you don't realize that you just square rooted to solve for x, which means that you have to look at doing plus or minus, you risk being half wrong on your final answer. So important. Do plus or minus on this one so you can get that possible second answer. Subtract the 3 over, you got -3 plus or minus 8. So I'm going to do -3 plus 8, which is 5. I'm going to do -3 minus 8, which is -11. Run those two at the top and check them. Both of these should work. I plug in 5, I get 8 in there. 8 to the 2/3 is 4. If I plug in -11 right here, I get -8. -8 to the 2/3 is also 4. Because the 3rd root of -8 is -2, and -2 squared is 4. So both of these work. Okay, example 3. This one's a little different. Still get the root alone. And you go to square both sides. What's different about this one is you have to square the sides. So we're squaring x plus 3 on the right. The left just turns into a plain old x plus 3. It just gets rid of the square root. But the right is a square dance situation. You've got x plus 3 quantity squared. So you're going to do first one squared, twice the product, last one squared. Well, now we've got a quadratic situation. It's x squared, so it's a quadratic equation. So we're going to make this one equal 0 and either look to factor or quadratic formula. On your assignments, they're all going to be factorable in this section, so I would just go ahead and get them factored. Most of them are pretty easily factored. This turns into x squared plus 5x plus 6. What times what is 6 adds up to 5, 2, and 3. So possible answers are -2 and -3. It's possible answers because we have to square up here. Whenever you square, you might get extra solutions. So plugging in 2, plugging in -2, plugging in -3. If I plug in -2, I get the square root of 1 is 1, 1 minus 3 is -2, so that one works. And if I plug in -3, I get 0 minus 3 equals -3. That one works too. So this is another case where they both do work. Doesn't always happen that way. All right, moving on. Example 4. Got one root, we're going to isolate it. I will start off by saying, is this a situation that you should go, whoa, 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 we got two solutions, plus, minus? And hopefully you're saying no, because this is odd up top. Odd up top. So, one answer, no plus, minus. And we're just going to go ahead and get the root alone. That's 7. Divided by 5. Now you've got the root alone, and I'm saying the cleanest way to do this is to power both sides by the reciprocal, which is 4/3. That cancels the 3 and the 4 over here, just leaves me with x minus 2. On the right here, I'm essentially doing the 3rd root of 27 to the 4th. That's 3 to the 4th, which is 81. Add 2, you get 83. You can check it up top. This one will work. Okay, we're going to finish off. We've got two radicals. Oh, looks like I left my stuff up here from a previous lesson, so go ahead and get that erased. And a little bit more. See, it was kind of a long problem. All right, so now we've got two radicals. Well, if you've got two radicals, you're going to make it so that there's one on each side. So instead of having a negative, this amounts to this. That's really what that is. It's one big term. So instead of leaving that negative, we're just going to move it to the right. And it turns into a positive. Everything else stays the same about it. And I'm going to say, well, I got to get rid of these powers up here, so I need to come up with something that gets rid of both a half and a fourth. If you power by 2, that doesn't do it, because you'd end up with a half over here. You'd go 2 times the fourth is a half. So it turns out you have to multiply, or power I should say, by the common denominator here, which would be 4. So I just power both sides by 4. That'll get rid of the 1/4 on the right. 1/4 times 4, that makes 1. On the left, you got a half times 4 is 2. Then you got a squared and situation on the left. First one squared, twice the product, last one squared. Equals 5 minus 2x. This is a quadratic. I'm going to make it equal 0. I'm going to add the 2x over, make it 12x. I'm going to subtract the 5, make it plus 20. And I'm going to factor what times what is 20 and adds up to 12. That's 2 and 10. So possible solutions are -2 and -10. Have to check them because I did a square, which can create answers. And if you go to check it, you should go and see that when I plug in -10, I got a bad situation because you end up with -5 to the 1/2. -10 plus 5 is -5. So I'm asking you to do the square root of -5, and that's not doable. You're going to get imaginary. So -10 doesn't work. Cross that one out. And if I plug in -2, I'm going to get 3 to the 1/2 minus, I got 5 minus 2 times -2. That's 5 plus 4. That's 9. That's the going to be the 4th root of 9. Or 9 to the 1/4. I guess I'll write it exponential form. And that's supposed to equal 0. Now some of you might be saying, well, that doesn't equal 0, but remember, this is probably the 3rd or 4th time I've done this, that the 4th root of 9 has a relationship to the square root of 3. They are the same. The 4th root of 9 is the square root of 3 because 9 is 3 squared. And if you take that to the fourth, you multiply and get 3 to the half. And they do equal 0. So positive 2, or excuse me, negative 2 does work, but negative 10 didn't. Now, I decided to add a little extra problem, or add a problem that isn't in your notes. So I'll go through that here quickly, but you'll have to have another sheet of paper out for that. It was number 44 on page 395. And it looks like this. Square root of 3 minus x plus square root of x plus 2 equals 3. So we just did one where it equals 0. It wasn't too bad. We just moved them over and powered both sides. Well, here I got equals 3. You still do the same thing. You move one over, get it so that we have a radical on each side. So I'm just going to subtract over the square root of x plus 2. And you're going to square both sides. Well, we've got some serious square dancing to do on the right, because you don't have nice easy numbers to work with. You actually have this square root of x plus 2. So what does this turn into? 3 minus x on the left. And on the right, you got first one squared, which is 9. 3 times 3. And you got to do twice the product. Well, 3 times negative square root of x plus 2 doubled is negative 6 square root of x plus 2. Double 3, you get 6, and then the 6 goes outside of the square root of x plus 2. Then you have to do last one squared. Well, if I square a negative, I get a positive. And if I square this term right here, not only do I get a positive, but the root goes away, and I get x plus 2. So you have a couple, 3 problems like that where you actually end up doing a square dance with a binomial that has a square root. And when you do that, you end up with a square root, which is okay. It just means we've got a long problem to work with. So now I've got it down to 1 square root. So what am I going to do? I'm going to get that square root alone. You first might want to say that 9 plus 2 is 11. But then it's, I've got 1 square root, let's get it alone. So I'm going to minus 11. I'm going to subtract x. That's going to give me negative 8 minus 2x equals negative 6 square root of x plus 2. Now I have to divide both sides by negative 6. If I do that, that gives me square root of x plus 2 equals. On the left, I can tidy this up a little bit. 2 goes into all 3 terms, and so does a negative. So I'm going to take a negative 2 out of all of them. So the negative 8 will turn into a 4 if I divide it by negative 2. The negative 2x will turn into a positive 1x. And the negative 2 on the bottom, take it out of there, I get a positive 3. Now I square both sides. So I'm going to get rid of the square root. If I square both sides, I get x plus 2 on the right. On the left, I get a 9 on the bottom. And the top, I got to do the square dance. I got 4 plus x quantity squared. So that'd be 16, first one squared, twice the product, last one squared. All right, been a long problem, I know, but we're almost there. See, I got a quadratic over here, I got an x squared. I'm going to clean this up now by saying I don't need this 9 in the denominator. I don't really like that, so I'm going to multiply that over. It's like cross multiplying. So that would give me a 9x plus 18 over here if I took 9 and took it times x, and then 9 times 2. And I got a quadratic. I'm going to leave the x squared on the left. I'm going to minus the 9x over. That'll give me minus x. I'm going to minus the 18 over. That'll give me minus 2. Nice easy quadratic to work with. 1 times 1 is negative 2. It adds up to negative 1. X minus 2, x plus 1. Possible answers are 2 and -1. I say possible because we squared. We squared not only once, but twice. So you need to go all the way back up, go back to the beginning, plug in a 2, plug in a -1, make sure it works. And if you plug in a 2, you get 1, and you get 2 here, because the square root of 4 is 2. And those work. 1 plus 2 is 3. And then we're going to plug in a -1. Put in a -1 right here. I'm going to get the square root of 4, which is 2. Plug in a -1 right here. I get square root of 1, which is 1. And 2 plus 1 is 3. So these both work. So very involved problem. Lots of areas where you can make a mistake. Important to get good at this. So as we go into higher math, we're not getting hung up on the algebra. Thanks for watching. Have a great day.